Can we recall once?
Yes, sir. So we have that Excel.
Can you share the Excel? Can you share that Excel?
One second. I've started sharing. You can let me know once it is visible.
Yes, I can see your screen.
So this is the sales data that we have. Based on the cumulative value, we have categorized as category A, B, and C, so that we can decide what would be the forecasting method accordingly.
This is for multiple line items. Multiple line items, and this is also using multiple forecasting models based upon the pattern of the multiple line items.
Yes.
Okay, so here, so we did. We have used. What we did here. We tried to find the skewness. What is the reason of finding the skewness here?
So skewness. I think we found the skewness so that we can understand how the data looks like. So if the data is not so much skewed, then it means there is not a lot of variation in terms of data. The data is heavily right or left skewed, then it means that there is a lot of internal variation, and from the forecasting model, it will not be easy for the forecasting model to predict.
Yeah. So, if, what was the range we discussed for the skewness? If there is a stable range, what is a no skewness range? What is high skewness range?
Okay, so I'm also looking for that formula. This formula is not here. Okay, so this one tells us, so if it is less than 0.07, it is low skew. Less than 1.5, like between 0.07 and 1.5, this is low skew. Anything above 1.5, this one should be high skew.
Okay. So, if skewness is high, suppose the skewness is low, are we going to receive high error in forecasting with the ordinary models, or we're going to receive less error with the ordinary models? We are actually we are noticing a very low skewness. In that case, if we have a low skewness, if we use a ordinary forecasting model which does not take into account the patterns, in that case, will we are going to receive a low error or a high error?
I think we would a model would do well.
So how do we define an ordinary model? And suppose from the technical point of view, how if somebody asks us to define an ordinary model and a non-ordinary model, so how would we define that?
I would say a complex model would be one which would continuously, update its logic based on the difference between the actual and the forecast. So if it forecast 5 and the actual is 3, based on that delta of 2, there would be an iterative step which would try to, for the next set of data, it will try to reduce the difference based on the learning, or whether it is under forecasting or over forecasting. A simpler model won't have that iterative logic.
Okay. So instead of suppose if we have a high skew, suppose we have a high skewness. So instead of going for a model which is iterative or which is more which takes pattern into account, instead of that, can we actually try to find the reasons of high skewness and reduce the skewness?
Just trying to think through. So the input data may not be under our control. For example, if it is sales, the sales data is highly skewed. That should be because that's how the company sales are distributed across a country or region. It's not evenly distributed, or the pattern is not, it's not a normal curve. So input data is not under our control. So my first thought is that we may not be able to control that. If it's the outcome of a manufacturing process, then maybe we can do some tweaking. But if the outcome is through a natural process, then we may not be able to change it.
Okay, so how can we decide that the outcome means the input data? The input data input data can be controlled for reducing its skewness. How can we actually how can we decide that? What are the statistical parameters which we have to take into account to understand that input data is under control to reduce to reduce its skewness, or not, or we are not in a position to reduce its skewness? How can we decide those things?
That I cannot how we are going to decide it, if we can decide that. So on a very high level, I can say that if it's the outcome of a process within the industry, so if there is a process within the industry that is giving out, which is the input to process fee, in a scenario like that, we can control it. But if it is something like distribution of age of employees within an organization, so, or the population of a country, so those are natural variables, those cannot be controlled. Statistically, how we are going to say that, I'm not sure.
So we suppose we have a data, and the data is no, we nobody can suppose we cannot control customers, right? We can only inspire the customers. We can trigger the customers, but the customers will be triggered or will be inspired to buy the product. We don't know. Suppose we are launching a promotional scheme. Right? We launch a promotional scheme because we want to inspire the customer and trigger the sales from the customer, because we also give bulk offers. If some customer is buying bulk, we'll give more additional discounts. We launch combo offers so that we feel some customers are having the affinity, or the products have the affinity. So instead of selling the products individually, we can sell the products in combination. Right? We're trying to instigate, we're trying to inspire and trigger the sales from the customer. But we cannot go into the customer's house, or we cannot take the customer's wallet, take his card or take his money, to create the sales. We have to do something, right? So,
Yes.
for example, we did everything, but because of some event like Corona or COVID, or maybe there is a there is a strike in the city or in the locality, some or maybe something is causing the, even though the demand is there, even the customer wants to buy the product, he has the requirement, but he's not able to buy because he is not able to move towards the to the retail shop, or the deliveries the delivery boy is not able to pick up the product and deliver to the customer because he does not have the passage clear. So there are two scenarios. One scenario is where customer doesn't want to buy, but we are trying to trigger the sales. The second scenario, customer wants to buy, but we are not able to do the sales.
Yes.
Right? So there are two. These are all the scenario, the market scenario kind of aspects, right? So we cannot go to the customer's house and we cannot actually make the purchase, forcible purchase, or from the customer. So we cannot control. We can only inspire the customer. We can only inspire the customer to buy the product. So that is only. But as a data analyst, we are not have. We are only going to. We are going. We are not going to work on the operations. We're not working on the operations, right? As a data analyst, we are getting the data after the operations are done, or how to do the operations in future to get those kind of inputs or insights. We are a data analyst. We are not the operations people. So if we are a data analyst, we are not the operations people. So what we're going to receive, we're going to receive the data after the operations are completed. After the operations are completed, then we will receive the data as a data analyst, and we'll do the analysis. Or if after receiving the data, after doing the analysis, we will give suggestions that how to instigate or how to inspire the customer to trigger the sales, or how to minimize the risks so that we can improve the sales in future. That is what we can do. So now suppose we have a data and we cannot do anything. We cannot change any operation because whatever data we have, that's a historical data we have. And that historical data, once we receive it, the operations are completed. So we cannot change the history. We cannot change our past. We can only learn from the past. So if we want to learn from the past, we will do. After learning from the past, we will try to build the future so that we don't. If we can improve whatever is being done, and we can actually eliminate whatever inefficiencies were there in the past, so that we can build a better future. That is our role. So now we have a past, we have the history. Now I'm saying that we have a we have seen high skewness. So the reason of high skewness is there will be occurrences of low demand and there will be occurrences of high demand, and there is a imbalance between these occurrences. Right? There's an imbalance between these occurrences. Means the what we have a high volume, a high frequency of high volume demand, or maybe low frequency of low volume demand. The other side is we may be having a low frequency of high volume demand, or a high frequency of low volume demand. That is the imbalance. That's what we are getting. That is the reason of getting the skewness. Right?
Yes, sir. One point I was just thinking as you were speaking. So suppose if I go to 10. This is, I have not delved deep into the concept of skewness, but this is my understanding. This is the normal curve. So here the skewness could be 1. But if I have something like this, it is tilted to the left, or it is like this. So this is left skewed, this is right skewed. So this is how the distribution looks. In this case, this is how the distribution looks. In this case, this is the most normal case. So here, for the high value cases, the frequency is low. For the low value cases, the frequency is low. So somewhere in the middle, we are seeing a high frequency. So isn't this the normal case that for both the extremes, I'm going to see low frequencies?
Yeah. So see, if you look at here, the first graph is that we have equal distribution in between mean. Means the left side of mean and the right side of mean. We will see the left side of mean and the right side of mean. Right. So here the mean is not tilted towards high volume demand frequencies or low volume demand frequencies. Because the normal distribution curve is the curve of frequencies of the demand. Right? The normal distribution
Right.
curve
So
is
this
the
neither like right skewed
or left skewed. So there is equal distribution of the low volume frequencies and the high volume frequencies.
Right. So like both the if I'm talking about high values here, value high, low values, so both of them could be low. It's not like that. So extreme should be low on both the sides.
So no, the extremes is different. The definition of extreme is different from the definition of the left side of the mean and right side of the mean. We are saying low volume is on the left hand side of the mean and high volume is on the right hand side of the mean. It's not on the extreme side of the mean. Extreme, not on the extreme side. Of course, we know that they are low volume and right. What we're saying the equally distributed. So the low volume distribution or the low volume frequencies is on the left hand side of the mean here, and the high volume frequencies are on the right hand side of the mean here, right? And what we see here, they have equal distribution. Means the frequencies of low volume and the high volume have equal distribution because the mean is existing in between them, as center of them. Now instead of center, I'll say the center of them, right? So now if you look at the second graph, the second graph is if you draw the mean will be on the left hand side, not on the right hand side.
Yes, so the mean would be like somewhere here.
No, not there. It will be on even left, even left.
Okay.
Yeah, that it will be there.
Right. Okay. And it falls steeply like this.
Yes.
So there is a lot of on the left it is a steep fall. On the right it's more gradual.
Yeah. So if you see the left hand side, what we see here, the left hand side we have lesser number of low volume distribution. The frequency, right? The frequency of the low volume distribution is lesser as compared to the high volume distribution in the second graph.
Right. Yes.
Right? In the third graph, the mean will be on the extreme right side. Yeah. So what we see here, the volume of the high volume frequency distribution is lesser, and the low volume frequency distribution is higher. The first graph, yeah, the first graph is having zero skewness or minimal skewness. The second graph is having right skewness, and the third graph is having left skewness. So skewness is a bias, right? We can see it is bias. The bias towards the right hand side in the second graph. It means the low volume, high volume distribution means the high volume distributions are more. So if you see the sales, if you correlate with the sale, so what we see, the high volume sales are more in the right skewed graph. So we need to build high inventory. We need to be ready with the high volume inventories.
Yes, so for this one you were saying that because high volume sales are more, so inventory would be higher.
Correct. So we need to build high inventories. If we do not remove the skewness, suppose generally what happens is the operations become more difficult. The operations like inventory operations become very difficult if you have a right skewed or left skewed graph. The reason because the analyst or a decision maker does not keep this skew graph in mind.
Okay, so just being curious on the left side, if it is the left skew, so by left skewed I mean something like this. Here the mean would be somewhere over here. In this case, I see there the frequency of low volume transactions is lot more. So in this case, don't we have to keep less inventory, and that's why it is easier to predict?
Yeah, so if we talk about left skewed or right skewed, right? So in the if it is left skewed, it means the low volume frequencies are more. So in that case, we need to build low level of inventories. We should not go for high level of inventories because the high volume frequencies are very rarely occurring, rarely happening. Suppose if I have, can you put a value on the mean, some value like 100 below the mean, just on the x-axis? On the x-axis, put 100, right? Now, if you look at here, the left-hand side of mean is less than 100, and right-hand side of the mean is more than 100. So what are the occurrence? Suppose if I keep an inventory of 120, if I keep my
It
inventory,
will be an overstock scenario in most of the
yes. So what I will do, I will be first ordering 120, right? And then this is going to occupy my warehouse. And now what I will notice is the chances of getting sales more than 100 is very less. So I will be getting sales of 1 unit or 2 unit or 5 unit or 6 unit. So my days of supply is could be very high, could be very high if if I make a decision of keeping an inventory of more than 100 units. So if my days of supplies goes up, it is going to consume my warehouse space, it's going to take my carrying cost. The only advantage I'm going to get is the ordering cost or the purchase cost. The ordering cost will come down because I don't need to order frequently. And second, the purchase cost can also come down because I'm going if the buyer is able to generate savings. Otherwise, we will not get the negotiated cost savings also, because now we are buying. The requirement is most of the time the requirement will be of 1 unit or 2 unit or 5 unit or 6 unit or 7 unit, right? That will be the requirement. But what we are doing here, we are keeping an inventory of 100 units. So if you are keeping in an inventory of 120 units, so what we need to get is that we need to get a good cost saving from the supplier, because we are buying maybe a 10 purchase volumes together at one purchase. So in that case, we should be able to use our contracts. We should be able to use our cost save. We should be able to negotiate with suppliers for getting a discount for bulk purchase. If we are not able to achieve that also from here, then buying 100 units is not giving us any kind of value.
Yes.
So let's say if we add the probabilities, right? Because every frequency we can convert into probability, right? Suppose my 100 suppose we have 100, the mean is 100. What is the frequency of that 100? How many times historically we have received 100 units as a sales? Or maybe we can also go for cumulative frequency. How many times we have received sales less than equal to 100? So in that case, we will be able to generate a frequency, and from that frequency we can generate our probability. The probability is 70%. Less than 100 is, for example, 70%. So 70% of the time I will be getting a volume of less than 100, 70, 100, and 30% of the time I'll get more than 100. So for 30% of the time, when there is a chance of getting a demand of more than 100, I am actually keeping an inventory of 120 units. That is a biased decision. And this biased decision, which may be uninformed, because we do not have the insight, that 30% of the time only will get demand more than 100, and that is going to add a lot of inventory into the system, and which is going to cost us, our inventory space, carrying cost. And if you're not able to negotiate with customers, with supplier, then we are going to lose our discounts.
Right.
So it's a very skewness is a very important factor. It's a very important factor which we need to take into account, because that is going to give us. Of course, we don't need to draw this distribution curve for each and every line item. because we have a statistical metric for that.
Ratio.
We will see the metric and we'll try to understand, okay, there may be a problem here. So if we see a negative skewness, it may be left skewed. If it is a positive skewness, it is a right skewed. By looking at the sign itself, because in the column AF, the row number 6, right? In the column AF, the row number 6, which is minus 0.44, this means it's a left skewed.
Yes, medium left.
Left skewed, right? So we now understand that if it's left skewed means it will be having low frequency distribution, high frequency, high volume, a high frequency distribution of low volume items.
Right. Yes.
So we need to be very careful. So when we are doing the inventory decisions, so we need to take into account of our skewness, and based on the skewness, we can actually. Now the question here is that we come back to this square one, that how we can reduce our skewness, because one thing is very clear, that we are data analysts. We cannot control the operations, right? We will receive the data, and after receiving the data, we have to make a decision. And for that, we need to, suppose if we get an opportunity to reduce the skewness statistically, how would we reduce this skewness? What are the,
If we can remove the outliers.
correct? Right, that's one of the areas we can work. If you can remove some of the outliers, hello.
Yes,
Yeah.
we can remove the outliers, then the skewness will reduce.
Yes. So if outliers means, if you go back to that paint, the paint picture, and go back to paint. Just now we figured out, yeah. So where are the outliers in this? In the first graph, we have almost balance. In the second graph, where are those outliers present?
Maybe this part.
Yes, this may be this part. So these are the inliers, right? Inliers means they are the extreme. So we can, if you remove that, it will even if you remove some of the extreme points, right, on the left hand side, right, also get balance. It will move towards right hand side. If you remove some of the data points from the left hand side, means low volume,
Yes.
it will move towards the right hand side. The mean will move towards the right hand side. If you remove some of the right hand side data points, it will move towards the mean will move towards the right hand side. There are two things we can do. We can remove from other sides, or one of them. We can try to figure out from either sides. Suppose if you are removing some of the high volume items, then the mean will move toward right hand side. If you remove some of the low volume items, if you remove some of the low volume frequencies, then the mean will move towards the right hand side.
I had a question. So, if you remove some of the low volume items, then this is how the graph might look. So initially it was pick up a different colors. Initially it was like this. They've removed this part. So this is the part that I have removed. This is the mean. So this is how it would look. But yeah, the idea of removing outliers would be to ensure that now the two sides become near symmetrical. But if I remove something from the left, instead of this side is already low, it's not as wide as the right side. If I'm further removing things from the left, then are we achieving symmetry? Like that is what I was thinking.
Yeah, so here the effort is, so we have to be very careful, because we have to also look at your supply chain. Suppose if your supply chain is that, where we are difficult to get low volume items, customers will not, the suppliers will not give us low volume, because there is a minimum order quantity clause is there, right? If suppose we have minimum order quantity clause, so in that case, removing the left side is better,
All right, okay.
because customers will suppliers will not give us low volume orders.
Understood. We can have supply side constraints. Okay.
Right? So we have to understand those constraints also, because if you remove high volume items, means then we are putting into a trouble, because suppliers will not give us low volume items, and then we have to we have to accumulate 2 or 3 low volume items to make it a big volume, which is equivalent to or more than the minimum order quantity. So in that case, if we go with the low volume items, if we remove the low volume items, then this is going to complicate our decision making.
Understood.
So most of, if suppose if you are basing our theory of inventory decisions on based of the normal distribution curve, these are things we have to follow. But if your distribution is not normal, if your distribution is not normal, if the distribution itself is not normal,
Yes.
in that case we have to be very careful in adopting this normal distribution curve. We should not adopt the normal distribution curve. So we may have an
Understood. So I
exponent.
think I was recently doing some O9 course. O9 is also a tool on inventory optimization. So there it was saying for fast moving goods, they generally follow this normal curve. For certain slow moving items, but then the Poisson curve is more suited.
Correct. So for slow moving items, or maybe in even slow moving items, if they have the consistent demand, even if the so slow moving is okay. Yeah. Slow moving means itself it's inconsistent demand. So there is a low volume and slow volume. There are two different definitions out there. So low volume but consistent, then we can go for normal distribution. But if it is high volume but slow moving, and low volume and slow moving, in that case we may have to go for a Poisson distribution, or maybe we can also convert them into an exponential distribution.
Right.
So we have discussed that one of the parameters is that we can remove the outliers, and we have to remove the outliers from which particular direction. And also we have to discuss. And third thing is that if you have a zero demand, right, it's not completely intermittent, but there will be some kind of missing demands will be there. So how to replace those missing demands? If it is inconsistent, if it is intermittent demand, we will not replace the zero demand with some value. If we have if you have the 100% confirmation, this given item is having an intermittent demand. Intermittent demand is one of the nature of the demand. So in that case, we will not replace the missing values. Right? If we do not have the intermittent demand, but there are some kind of gaps are there in demand, in that case, we're going to replace the. If suppose if we get the approval from the sales and operation planning meeting, right? We have to discuss those things in the sales and operation planning meeting. We have to tell the operations guy, there are some missing items, there are some couple of missing demands are there. So can we put some minimal demand there?
Right. So can we not put the median value on our own median or mean value?
Yes, we can go median value, we can go mean value, we can go average, mean, average, median, max. So we can also go for the standard deviation, right? 1 into standard deviation, 2 into standard deviation. There are various kind of simulations we can create. So we have to
Right.
see.
Like missing one imputation, we can plug in a value. Understood.
Correct. So for intermittent demand, we will not touch anything, because we already know that the nature of the demand is intermittent, because we're not going to receive consistent demand for the particular line item. But if we have some consistency, few of the periods are not having the sales, in that case we can go with the. And the second factor is lead time, right? Suppose we have we have taken a data and the time horizon is 1 week. So we are making a forecast. We're creating a forecast for, we are trying to get the sales history for each and every week. Right? We're getting a sales history for each and every week. Okay, but the lead time of supply is 2 weeks. The lead time of supply is 2 weeks. So here we can match our time horizon with the lead time of supply. So let's, instead of,
Can you repeat this example once? I could not follow it.
yeah, see, if the lead time, if suppose we have our sales history, which we have our sales data, which we have captured, right? That is week wise. So week 1 we had a sales of 20 units. Week 2 we had a sales of 50 units. Week 3 we have a sales of 10 units. Week 4 we do not have sales.
Okay.
Right now, if you look at week 4 and week 3, week 3 we had 10 units of sale. Week 4 we have 0 units of sale. So week 3 plus week 4 is how much? 10 units only. Because week 4 is 0 units.
All right. Okay.
So if we see such kinds of scenarios where we have, but scenarios where we have 1 week is having a sale and second week is not having a sale,
Erratic demand.
right? So we will say this is, we, instead of calling it sporadic demand, okay, it may be sporadic. It is sporadic because they're trying to capture data by week wise. But if we capture the data by 14 days, fortnight, if you capture the data by fortnight,
Yes, then it is not.
it's not sporadic. So now, now we have to make a decision whether we shall go with the data week wise or fortnight wise. That depends upon our lead time of supply. Supplier's lead time is 2 weeks. Why shouldn't we go with our forecast time horizon as 2 weeks? So we will try to do the replenishment process every 2 weeks.
Right, but if we increase the size of the bucket, then any intermittent data will start appearing uniform. So if I have sales like 15 days, then for the next 2 months there is no sale. Again, there is sales for another 20 days, no sales for the next 20 days. But if we put it into like 6 months bucket, then it will start appearing uniform because those periods of no sales, they will be clubbed with the period of sales. This we are going to do this or not depends on the lead time. If the lead time is 6 months, then clubbing it into buckets of 6 months is fine. Is that what we are discussing?
Yeah. So here, if we suppose we are trying to if we are trying to compare the replenishment cycle with the consumption cycle. Here we're trying to compare the replenishment versus consumption cycle. So if my consumption, so if I make the analysis of consumption day wise, but my replenishment is happening every 6 months, right? So we'll get the minute understanding. We get a minute understanding about what is my daily sales rate, whether my days of supply, which is based upon 6 months, right, is going to meet or not. That's why we're going on the minute scale of day wise. Right. So I'm not trying to see. I am. So what is the purpose here? The most important thing is the purpose. If you are making a time horizon of forecast, what is the purpose? It's not just we take the data week wise or day wise or 2 weeks or 3 weeks or 1 month, right? We are making the choices of the time horizon based upon some purpose. That purpose has to be clear. What I'm saying, that purpose has to be clear. If my purpose is to understand the minute scale of consumption of my consumption, because I want to understand whether my expected sales rate is 10 per unit, 10 per day. If my 10 per day means it is for 300 per month, so it is 600 for 6 months. It is 1800 per month. So I will be giving the next order on based on 6 months lead time. Right? So today is my first day, and now I have to give I am giving an order of 1800 to the supplier to be replenished on the 180th day. Why I'm giving the order supplier on today to be replenished on the 180th day because my per month demand is 10 per unit, which is what we're going. Now, suppose if my per month demand, per month consumption goes from 10 to 20 units, and now I've already placed the order. I've already placed order to the supplier of 180 units, which is going to be replenished on the 180th day, which is 6 months from now. Now, what we're seeing is suddenly demand has peaked up, and now it is from the demand is now the consumption is moved from 10 to 20 units. So what I will see here is that now the replenishment has to be done not on the 180th day, but it has to be done on the 90th day. If its replenishment has to be 90th day, then what I have to do? I have to find my alternate supplies, because that supplier will not give me the order in the third month. At the end of third month, because the supplier return order is fixed 6 months. Now I have to find the alternate sources so that I can replenish my stock, because now my consumption, which was 10 per day, has risen up to 20 per day. So that is why we are going for understanding about the minute, going to go do the analysis on the minute basis. But if you are sure that you don't need to do such minute analysis, you can go with, now I want to do analysis by month wise, how much I require month wise, because you're sure that day wise variations are very less. If you're sure the standard deviation of day wise sales is very less, or the day wise sales doesn't happen, day wise sale doesn't happen, either the sales happen every 14 days. It's not FMCG, it's not FMCG product where where we have sales every day. It is something else. The nature of sales something else, means we are not selling every day. Sales are happening every 4th day or every 10th day or 15th day. So there is no point of doing analysis day wise there, because we know that the sale doesn't happen day wise. So if we capture day wise sale, we will see there is a sporadic nature, there is an intermittent nature, because the sale doesn't happen there. That's not the nature of the product. So we have to understand the nature of the product, the sales nature of the product, as well as our replenishment cycles, and then based upon that only we have to come up with the time horizon. So the balance between the sales and the replenishment has to be taken into account while deciding our time horizon. Then only we will be able to do right analysis. Otherwise, we will not be able to do. So we will be able to capture the right distributions.
So we were just thinking. So for example, there is a company in India which is selling laptops. So that sale is not a daily sales. For example, in terms of the sales, so someday I'm selling like 10 units, someday I'm selling 15 units, and there is some amount of seasonality. For example, I'm selling more during the festive times. And when I'm getting the supplies, maybe it is dependent on the global supply chains, the semiconductor from China and all of that. And overall, it takes 6 months for me to procure the raw materials. So in that case, what would be the right bucket?
Can you repeat the question once again?
Yes. So I'm saying that there's a laptop manufacturing company in India which is selling in daily buckets. So every day there is some sale, but the supply lead time is 6 months. It is getting the different raw materials from China and all of that. So in that scenario, what will be the right bucket?
Yeah, the right bucket is we'll go with 6 months only, because we're not going to order every day, or we're not going to order every month, right? So I'll go with 6 months, 6 month cycle. What is demand in the first 6 months? What is demand in the next 6 months? What is demand in third 6 months?
Okay, so here the supply side decides what the bucket will be.
Yeah, because there's no point of the only point of making a day-wise analysis is whether my expected day-wise sales is matching my actual day-wise sale. Right? Suppose I'm the supplier is going to make 6 months replenishment. Okay. So how much I need to order for the 6 months? Right? How much I need to order for the 6 months? So I will be, suppose if I have the historical data with me. Okay, if I have the last 5 years data. If I have last 5 years data, I'll not go with day-wise sales. I'll go with 6 months sales. So in the last 5 years, I'll get 10 data. 10 my sample point will be 10.
Yes, 5 plus 2, 10, right.
Right. I'll be having two sample points per year. So we have 5 years. So 10 sample points I will have. So I will make I'll make a prediction on the basis of 10 data points. Now, if I start thinking that the sample point is too less, the 10 sample points are too less, then I'll go with let's go instead of 6 months, let's go to 3 months. In this case, sample points will be 20 points. But still, my decision will be based upon 6 months only, not on the basis of 3 months. I'll make a forecast. I make a forecast on the basis of 3 months, but my aggregation will be done on the basis of 6 months. So if I say, okay, no, 20 data points are too, sample point of 20 data points are too less. Now I'll make 1.5 months, 45 days. It will become 40 data points. But again, even if I make 1.5 months as my one time horizon, but my decision will be based upon 6 months only. So why I'm making it more granular? Right? Why I'm making it more granular? The reason of making it more granular is to capture the variability. To capture the variability. Why are we increasing the sample points from 10 to 20, 20 to 40? We're increasing the granularity because we want to capture the variability. So that is why the purpose is very clear. The purpose is very, very clear. I am going to make my decision based on 6 months only, but I am just trying to capture the variability. That's why I'm trying to make it more granular. The time horizon is a very important decision, but we need to see that why are we making this time? Why are we choosing a specific time horizon? And what are we going to do with the time horizon? Even if I break it into 1.5 months or 1 month or 15 days or 30 days or 1 week, my decisions will be based upon 6 months only because my supplier lead time is 6 months and I have to order it on the base of 6 months accumulated demand. Even if I make it 1 day granularity, even if I bring the 1 day granularity also, my decision will be I have to aggregate the demand for 6 months because that is how supplier is going to deliver to me. In this case, we only for sample point, we only for increasing the sample points and to get the understanding of the variability, we're increasing our sample size. But in some cases, we don't need that granularity also, where we have a mapping between the lead time and the or time horizon. If we have good sample of good sample points, good sample, where I don't need the granularity, I will not go for granularity.
Understood.
Time horizon is very critical. It can impact our distribution. It can impact our accuracy. Yeah, can you go back to the Excel?
Sure.
So let's review once more the TSB model, right? So take one of the data point and one of the item, which has which has intermittent demand, and transpose it into a different sheet. Take any one which has the intermittent demand, and transpose the data into another sheet, and we'll do one TSB.
Understood. So intermittent demand, right?
Yep.
So here there is no column that tells me clearly whether it's an intermittent demand or not. I'm trying to figure out.
Look at all the no patterns, no pattern one, where we do not have any patterns. In the column AQ, you can check where we do not have any patterns. Low, low trend, low seasonality, no seasonality. Yeah, check this one.
This is low trend and that is no seasonality. And so can I pick up this item?
No, that is not the that is having some demand there. You can go with the row number 30, row number 37.
Zero. Okay.
Yeah.
Move it to the end. And the part would be all right. So we have copied the data. So should I remove the part from A or do we need?
Yeah, we just don't put data into remove all those things. Just remove everything from column AF till last, and put them in the put the historical demand in the columnar structure instead of the row in the form of row, and also remove this product code and everything, product code, customer code, everything. You remove. Just only keep the sales data. Yeah. Now what you do is that to make the data into a columnar structure.
So does it look fine now?
Yeah. Okay. Now we have a product code. We have our sales data. Now we have to do our. We have to apply our intermittent forecasting model. Intermittent. If we have a data, if we have a sales or disbursements or issues of a particular item or a product, and if we have a nature of the intermittent demand, then we are going to use one forecasting, which is very advanced forecasting model, that is called TSB forecasting model. So how we are going to apply here? I think we have discussed TSB model, right? So can you try? Can you try it from your side?
I had revised that, but I did not recollect this model part right now. I can have a look and work on this as a homework for tomorrow's class.
Mhm. Okay, let's. So you remember single exponential smoothing?
Yes, the basics of it little bit, but not very fully.
Okay. So let's first. We are in TSB model. We know two things, right? We have to predict what we have to predict our volume, and we have to predict our periods, right? How many periods we will have demand? How many periods we will not have demand? And if we have a demand, then what is the demand? Right? That is what the prediction we do in intermittent forecasting.
Yes.
So suppose if you look at the first one, can you write a formula that if it is 0, give us 1, or else give us, we want to count how many zeros are there, right? We want to count how many zeros are there. So let's create a formula to count how many zeros are there. No, not together. We want next to them in the column.
Okay.
It's a very important formula. We are not getting how many, right? We are getting here. Whenever we're getting 0, we're getting a 1.
Okay, so do you want this number to become
2.
Okay. You just make an update now. Drag this with this. So this is from. So here it is 3, here it is 4, the 4 stays open. So now I think it is working. It's fine.
Yeah. So now we have a understanding that wherever it is 0, right, it is 1, and we're cumulatively we're adding the count of zeros.
Okay.
So now if you see, look at your 2, if you look at the 2, row number 7, right? In this case, we will have a demand after, we will have a 0 after 2 periods, right?
Yes.
Now, if you look at the second, the third 0,
Third 0.
yeah, what is the meaning of this? We will have 3 periods of zeros.
Yes. But you know what? Again, there is a fourth 0. There is no uniformity. Like, do we know after how many periods you're getting 0?
Yeah, that also we will do. That also we will do. That also we will do. Right? That also we will do. Now subtract this. In the column E, subtract the 2 consecutive. In the column E, subtract the 2 consecutive values. So you have to start from 6 here. 1 minus D5, D6 minus D5. Yeah, now drag the formula. Okay. Now if you look at here, the first one, yeah. So the first one, if you see, there is 0 there. So here, so what we will do, the first, instead of putting first one is 0, we'll put 1 there. The first, only the first one, only the first one. We'll put 1 there. Yeah. Just put manually 1 there. Okay, now everything's fine. Now suppose the demand for the second period is 3,45,600.
Okay.
and this demand is going to come after 1 0.
Okay.
So we have to make this purchase for how many periods? Two periods. Because the above period, and suppose if I make a purchase on August, if I make a purchase in the period of August, so this has to be survived for 2 periods, August and September.
It should survive for 2 periods, September and like shouldn't it survive for 3 periods, like these 3?
Correct. That also will go. We can also go with 3 periods, right? So here, if you look at here, so the first period and the second period, that is 1 and 1 in the column number E. Even if you make a purchase, even if you make a purchase, let's go one by one. If you make a purchase in the period of August, let's say it should run for 2 periods. For example, first August and September.
Okay.
Now, if you have to make a next purchase, you have to make a next purchase, which is for the month of October. In the month of October.
Okay.
So how many periods should run? 2 periods.
Okay. I was thinking 4, but okay, we'll go through now.
Yeah, 2 periods. So I have to purchase 1267,200, and that should be able to run for 2 periods. Now I have to make a third purchase.
Another 2 periods.
Now 3 periods.
Okay, now these 3 should be.
This 3 will be.
Sir, I'm not understanding. Like, how are you saying it's 2 or 3? Like, on what basis?
Yeah, so we have to see how many periods we have to. Suppose in the first case, if you look at here, the first scenario, the first 0 is coming at 1. Column D. Let's look at column D first.
Okay.
Right. So if you're looking 0 there, 0 is coming 1 there.
0 is coming 1 time, all right.
Yeah. Next is what? Again, next is 0.
Okay, so we are going to go until we have a next value.
Correct.
But this one works, if I already know the data, but when I'm forecasting, then you not have the advantage of looking ahead and knowing whether it will be 0 or a number.
We will have, if we have the input, right? If we have the input, then we will know when we have demand, when we do not have demand. If we have a demand, circle demand, then we know when we have a demand, when we do not have a demand.
I get that, but it's not always. For example, here it's like 3. There are 2 zeros, and then I have a number. So, how do I know that 2 would be the number that we'll always purchase for 2? It is also 3 at times.
Yeah, that's what we have to do. We have to come up with the number there, because right now we have when we have a demand, we are getting that, right? So we have to create a formula there that we should give us an actual number there. Right now, suppose we look at here 1011 1011, we are getting column C. In the column D, we are getting the cumulative number there.
Yes.
So it should start, if it is, if there is 0, we should stop there. Then again do the recomputation, recumulation. Right now, what we're doing here is that we're doing the overall accumulation in the column number D. What we need to do there, suppose if we are starting from the column B, if it is 0, give us 1, column C. The column C, if it is 0, give us 1. Column C, not D, column C. Yeah. So if it is 0, column C. If you're getting 0, then give us 1. If it is demand, stop at 0. Then again do the recalculations. 1 0, that's okay, fine. Now when we do the accumulation, it should 1 plus the first number is 1, second number is 1 plus 0 1. The third number, you should again start from 1, the column D.
Understood. Okay.
the third number in the column D, it should again begin with 1. Then in this case, the fourth number will be 1. The fourth number will be again 1 because we are going to do the accumulation. The fifth number should not be 3. The fifth number should be again 1 because we are getting a fresh 0 there.
Okay, so this chain of summing up stops the moment I have a number other than 0.
Correct.
Thinking how we can have that. I can run if there. If this person, okay, let us first come out of this one. So right now, this is the cumulative sum of zeros, then it is the sum. Okay. So I'm going to do the sum only if this is cumulative sum of zeros. So this is just, I'm just adding from C5 to D5. So I'm going to do the sum only if this is zero. If I do not see, I'm going to do the sum. Okay, I'm going to do the sum only if it is a 1 over here. If it is 0 over here, then I'll simply put that as this is. What do I do? So if this number that I have, if this one is equals to 1, then I do the sum. Else I put a 0. The if. Let's drag and see how it goes right now. This 1 is fine. Here it was a number, it became 0. Okay. Now here it should begin from 1. If C7 is 1, then actually there's a problem. It is coming up from C5. That it should not do.
Here it should not come again. It should start with 1, right, instead of 2.
Okay, so I think here when I'm summing up, I'm starting from C5. It should not be from C5. It should be from the last time when there was a 0.
Okay, let's start the formula once again. Let's go to first formula. First D5, D5, D for Delhi. Not B5, Delhi. D for Delhi.
Okay, D5. Okay.
So let's start the formula there. If C5 is equal to 1,
is equals to 1,
comma 1.
Okay, if this was 1, then I'm taking 1.
Or else 0. Wait. We have to still do. Now we'll go to second formula. Go to second formula.
Sure.
D5 is done, right? Now go to D6. Right formula. If C6 is equal to C6 is equal to 1, then
C6 is equals to
1,
and then
right? Then we will do D5, right? The other one, D5.
Then sum of D5, right?
Yeah, no, not sum of. Simply write D5 plus C6. If C6 is equal to 1, we have to, if C6 is equal to 1 means we are going to stop there, right? If 1 is there, we're going to stop. If it is 1 is going to, no, we're going to count. If 1 is there, we're going to count. Yeah. If it is 0, then we can also take d5 plus 0. Yeah. Now, okay, if c6 equal to 1, if c6 is equal to 1, then we are going to take d5 plus d6. So if you wait, d5 plus d6, no, still it's not done. So d5 plus d6. No, we have to improve the formula. Yes. So if c6 is equal to 1, then we are going to do d5 plus d6. If it is 0, if it is 0, then what we're going to do? We're going to show 1 there. Or d5 or d6 or d6. Remove 0 there, put d6 there. Enter and drag it now. Why it's not happening? Now here it is. If c6 equal to 1, c6 equal to 1, the d5 plus d5. What is d5 here?
So C6 is 0 here, so that's why it is coming as 0.
Instead of d6, instead of d6 plus c6, put c6 instead of d5. Put d5 is what? d5 is 1, right? d5 is 1. So d5 plus c6. Make it d6 not. Don't make it d5. c6. d5 plus c6. Now enter and drag the formula. It's not getting. So here, if it is 0, if it is c6 is equal to 1, if c6 is equal to 1, then we want d5 plus c6. If d6 is if c6 is equal to not 1, then we want d5. Put d5 there instead of d6. Last the else option. Yeah, d5. Yeah, enter and drag. Okay, now we'll see what is the improvement we need. So second one is coming right. Third one is not coming. If it is 1, if it is 1, then okay, now here what we do is,
so here should it not start from 0? So it's a number over here, so it should cumulative sum should become 0.
here it is 0. If number is 0.
Should it not be 0? That's what I was thinking.
No. We have to take the previous value. So what we have to do improvement here is, if C6 is equal to 1, then we are taking the sum of the previous value and the C6. So if it is C6 is equal to Z, if C6 is equal to 0, if C6 is equal to 0, the next value is, we have to go with the next value. Okay, now we have to go C6 equal to 1, and if C6 is equal to 1, then we need to have 1 here. So instead of d5, put 1 there. Instead of d5,
Last.
yeah, put 1. Yeah, drag the formula. Now let's check.
So I get a 0, this is 1. This is a number here. So should it remain 1 or should it become 0?
So what we have to, what we have to pick here is how many. So what we have to is how many, after how many 0 we get a demand. After how many zeros we got a demand. That is coming right in the second case. After 1 0 we got a demand.
Okay.
Now second question is, how, suppose the second one, it should come. If it is 0, then we should get 0 there. Okay, now go back to second one, second formula d6, and instead of 1 put 0 there. If you put 0, how much you get? d6. D for Delhi.
D6.
D, yeah. D6, and put instead of 1 0 there. Yeah. Now enter. Now you see. So after how many 0 we got a demand?
So
1. So here 1 after 1.
So a zero, this number beside a zero, this is going to tell me how many zeros are immediately before this one.
Correct.
That is common, correct?
Correct. So now let's create a column. Yes. So now
C10 is equals to 1, then B9 plus C10. B9 was this one and this one I am adding, all right. Okay, and if it is not, then I'm saying 0. Okay. Yes, we wanted to create a column. Should I create it here?
create a column there. Now go to the T6. E6, sorry, E6. E6.
Okay.
Yeah, write a formula. If equal to if D6 equal to 0.
If D6 is equals to 0,
Give me D5.
D5
Else blank. I think you have to put inverted comma, double inverted commas, two together. Drag the formula. Okay. So where we getting if it is there's one way it's not working. Well, if D6 is equal to 0, we want D5, right? Now we are getting able to understand here after how many zeros you get demand here. So 34560, 3,45,600. We're getting the demand after 110. Getting a demand 126720 after 10. D8, E8.
Yeah, it's telling me like, if I'm getting a period of no demand, then there are how many periods of demand before that?
No. It's the opposite way. If you're getting a demand, how many periods of no demand are there?
Okay, yes. Looking at this column, it should be from this one. So yes, if I'm getting a demand, how many periods of no demand are before that? That is 1. If I'm getting this, there are 2 periods of zero demand. That is why it's a 2. Okay.
Right? If you're getting 0 means there is a demand before that.
So I'll just put this heading. How many periods of zero demand receipt period of demand? Okay.
Right? So now we understand, right? So how many periods, suppose we have to make a purchase. So how many periods we need, for how many periods? Yeah, that is another procedure. No, there is another procedure. If you want to go with period wise, you can go with this one. If you want to go with overall wise, you can take the average of that. So if you go with overall average, you will not get accuracy. If you want to go with delta wise, break wise, breaking. If you want to keep deltas, then you will be able to understand how many periods I have to make a purchase. So remove the column F. This column F is not required now. So if you want to make a purchase for in August, you will make purchase for 2 periods.
I'm making a purchase in August is for 2 periods, that is August and September. Okay. Because in September I have 1, so there is a period of no demand. Okay, fine.
If it is 1, it means you have to make purchase for 2 periods. If it is 2, you have to make purchase for 3 periods.
All right. So in September, how many should I make any purchase, because the purchase of September has already been done?
Yeah, but you have to make a purchase in August, not in the month of September.
Yes, so August done. So August I am purchasing for 2 periods, August and September. So in September, I'm not purchasing anything.
September you want September end you'll go for the purchase. Or means September end you will go for the purchase, right?
I was thinking I should go for purchase in October.
Yeah, you can go for October also. Yeah, you can. That's what October also you can go purchase. September end means September, October beginning. So you can go for purchase in October, and that is for 2 periods.
Yes.
So
Because in October I check that in November this number is 1. Then I come back to October and place an order for it.
Correct.
All right, okay. So in December I check there is nothing. In Jan there is nothing. In February it is 2.
So you have to make
December,
3 periods.
Make it for 3 periods.
3
So,
periods.
so
If you
this
want,
would be my workflow.
yeah.
So in February I place an order for 3 periods, all right. In March, this number itself is 0. So I'll have to place an order in March for March itself.
Correct. Or you can make, or you can make a purchase, or you can make a purchase of February and March together.
All right, okay. Okay, so I'll have to look ahead for the future periods. What is this number over here, and then take a decision.
Correct. And then what is the rate of purchase? The rate of purchase is, suppose you're buying in the row number 6, you're buying a purchase, you're buying for 2 periods, August and September. So you're buying for 2 periods, it means it will be 345,600 by 2. It is
Why did you divide it by 2?
That is a rate of purchase, right? That is a rate of purchase. Means what you have to do is that, what is a purchase? You can put in column F. In the column F, you can put so purchase volume.
Purchase volume per month.
Per month, right? Now it is purchase volume per month. So in this case, if you are getting a demand in September, but you have to buy it for 2 months, and that will be 345,600 by 2.
What is the value of this metric? Like, what is the utility of calculating this metric?
Yeah. So you're not buying just for, you're buying it for September, but you're going to stock it for 2 periods. Buying it for September, but you're going to stock it for 2 periods. So the per period it is 345,600 by 2.
But if I'm buying in October, if I'm buying this 345,600, my storage space that will be the same. Like it will be for 345,600 for 2 months.
But what if you get a demand in the month of August, for example? Instead of September, you get demand, because we are not saying that this is, of course, there is this intermittent demand, but we are not going to say that we will not receive a demand in the month of August. You cannot project.
Okay, so there's a chance that I can.
Yes. August also. So in that case, if you get demand in August, you're buying considering that there will be demand in August. That is 172,800. In case if there is no demand in August, if you get demand in September, then you will see the consumption happening of both the months together. Even if there is the total consumption is not happening. Suppose you have a stock of 3,45,600. You have a total stock, and we are considering that there will be demand in August. So we are having some stock for that. In case if there is no demand in August, that will be demand in September. But in September, we are not getting demand equivalent to 3,45,600. We're getting demand equivalent to, let's say, 1 lakh. Right?
Okay.
So in that case, we will not buy for October. We'll buy lesser for October and November, because we have some of the stock which is not consumed, which is not sold. So in that case, we will be buying lesser for October and November together. What will be stock left? Suppose if we are in the month of August, there is no demand. In the month of September, we have a consumption of 1 lakh. So how much is left with us? 2,45,600. So what we will do? I'll not buy in the third case. In the third case, I will not buy 12 lakhs 67,200. I will not buy 12 lakhs 67,200. I'll buy 12 lakhs 67,200 minus 2 lakh 40,600. This is how it works. This is very complicated. This is
If I understand it correctly, so there is a lot of manual intervention.
correct.
It's not like the model gives me a value and I can directly plug that in.
Correct.
Like every period, I have to sit down and analyze how much of the stock is left and subtract and order accordingly.
Correct. Correct.
So is this the TSV
No,
model?
no. This is not TSV. This is not a TSV model. No, this is not a TSV model. This is a challenge which TSB faced, and he created a model out of this, where we don't need manual intervention every time.
Okay. Yeah.
So we need to understand what was the challenge. Now we have understood the challenge here. Right? We have understood the challenge here. There was, if you want to eliminate this challenge without without creating a TSC model. Suppose now TSC model is a very advanced model, okay, that doesn't require this kind of manual intervention every time. But without applying the TSB model, I want to eliminate this manual intervention. So the challenge here is, without applying the TSB model, which doesn't require the manual intervention, I want to eliminate this manual intervention at every stage without applying the advanced model of TSB. How will you achieve that?
Okay.
Just think for 2 minutes. If you are not able to, I'll help you.
Okay, understood. So without applying these model, how do we remove the manual intervention? So I was thinking, if we can look for a period of say 6 months, so starting August, I want to look for the next 6 months. So the average comes around 26800. Every time I place an order, it's not the perfect model, but it removes the manual intervention. So whenever I place an order, I place an order of this.
Okay. So here we can do two things. One thing we can do here is that take the average of the column E.
All right, yeah.
Take the average of the column E. So this is
0.8, it is even less than 1. So it's rounding up, it means 1.
every 1 period, right?
Yes,
Now,
so,
okay. Now we'll take the average of the column B.
Column B, okay.
What is the average of column B? 451.
4,50,000.
450,000, right? So now what we'll do, we'll take the average of the demand divided by the average of the periods having.
Okay.
So how many periods of zero demand we have? That we take the average of these two numbers, the average of column B and the average of the column E, and we'll divide them.
So, this is one average. This average gives me how many periods of zero demand precede a period of demand. So I'll take an average of the first one.
will not make it 0. No, will not. Let's get whatever numbers we get, 0.83, whatever. Let's divide these two numbers.
I was thinking, like, should I include this column?
Don't include that. Don't include that.
So this begins from E5. E5 is should begin from, it is still 0.83. So this 0.83 means the 0.83 periods of zero demand that is one period of demand. So
No, do one thing here. Also don't take any blanks also, because don't take any blanks. Just take only the pure numbers. In the case of column E, I think average A, right? It will be average A.
Returns the average of its arguments evaluating text and false true means the averages can be numbers. Does not say like it removes the spaces, but it comes down, so it's not considering the
I think we're
spaces.
considering the spaces also here. So we can use average if there. Average if can be used. Average if we can use. Average if.
Find the average.
More than 0. Anything more than
This is the
range.
The criteria is range criteria. Averages, this is optional. This is 1.25. I can do one thing. I can just take these numbers. I can independently calculate the average and see what it is doing. Let's remove those.
We take the blanks also. We'll remove the blanks. Yeah, I think it is taking the blanks consideration.
I can pick mentally 4, 6, 7, 9, 10. How many entries are there? So
Yeah, 1.25.
The sum is 1.25.
1.25.
This is correct.
Correct.
Okay, so trying to think, what this would mean.
So it is a rate of demand. This is a rate of demand.
Okay.
Now, if we divide this average by the periods, right? So this is a rate of demand. How much? What is the demand per period?
Does it not mean how many periods of zero demand that I have before a period of demand comes in?
Yes, that's what it means, right? 1.25 periods.
And then divide this number by this.
Now, if you see the column E, look at the column E. So if one we got, right? We got 1 there. In E6 we have 1. What is the meaning of E6 1? It means that we're going to get demand after 1 0. So we have so what we are going to do here is we're going to do 1 plus 1 2. Right? 1 plus 1 2 here. So here we're going to get a period for. So we have to multiply this with by. If it is 2, it will be 3. If it is 2, it will be 3.
Okay, yeah, it's plus 1.
Yeah. So now just do one thing. Just do one thing there. It will be 1 plus 1, 2.25. Now we can divide this. This is the average demand we'll get. This is what the average purchase we have to do. Average demand per period.
Right. Okay, sir, like why did we remove these zeros? Like should we not include these zeros as well?
It will not impact, right? See,
Okay, so what if we had we had included the zeros, it would have reduced this average. It means that this number would have gone up.
So if you reduce those numbers, right? So that if the zeros are there, zeros are not going to impact our sales rate or the purchase rate, because after we have to buy for the suppose if you buy this 2 lakh 7,000 2 lakh 7 20,000, right? 2 lakh 2 lakh 7 8 2 lakh 789, right? 2 lakh 789, that is what we have to purchase for each period. If you add zero there, doesn't make any sense, because that zero is equal to a demand period. The zero which you see in the column number 6,
Mhm.
that is we are getting a demand after every period over there.
Okay, so this is a number that I'm going to purchase like before the beginning of, like for every 2.25 periods, I'm going to purchase 2 lakh.
Correct.
This is how we interpret this number.
This is not every 2.425, every period now. We are dividing 451,776 divided by 2.25, and it becomes per period.
Okay.
451,776 divided by 2.25, it means now we are trying to compute, now we are finding for every period how much you have to buy.
All right.
So now every month we need to order this much.
Okay, and the removal of zeros part, can you explain one? So if I'm buying for every period, should we not be buying more now? Because if I include the zeros, this number is going to go up.
Yeah, so if you multiply this 200789 into how many periods we have?
We have 2.25 periods.
No, here in this case, this is means every 2.2 every 2 point, this means every 2.25 periods we require this much, 451,776.
Correct.
So if you buy every period 2000789, it means that every 2.25 periods you require 451,776.
Correct.
So now every 2.5 periods we need to have the availability of how much? 451,776.
Yes, correct.
Now it means if you want to add those, that is what we have to see. Now we are seeing that every 2.25 period we need to have 451,776. That is 22 lakh 789. 2 lakh 789, that is what we want. So this is going to remain constant will remain constant for throughout the period. So last, just check the last one. The last so let's put the number every 2.25 periods, and let's evaluate whether that is going to impact our no zero periods or not. So let's go to Excel on the top and put 2 lakhs inside a column before C. Inside a column before
Okay,
C,
sure.
yeah, and every 2.25 periods, right? So means let's say every two period, how much it will be? Let's factor before that. Let's factor it. Let's factor it out.
Okay.
So this is for
every 2 periods or every 2.25 periods?
yeah, this is for every 2.25 periods. So every 2 period, how much it will be? That is 20789 into 2 into 2.5. Let's calculate the number 202,00789. That number into 2 divided by 2.25. Into 2 divided by 2.4, close the bracket, and divided by 2.5. Okay, this is the number which we have to put every 2 periods. 178,479.4 means, let's say 178,480. 178, put every 2 periods, not in the top. Yeah,
This is quoting. So this one is going to cover for these two.
correct.
Drag is very intelligent enough to understand what's happening. And, not doing that correctly enough. Let's see how. Lost example. So I have put this, plugged in this number every 2 periods now.
Yes, how many periods are this? Just count it. We'll add by, and also do one thing. Now find the sum of the column B, not average, sum of column B.
This number is
Just find there, put the value there.
the number is so large.
Okay, what's the count of this? What is the count of periods?
Okay, so count of periods I can just see from here.
This is
We've got 25
25 periods, right? 25 periods we have. So as of now, we have taken how many? 12 periods. 12 periods here.
Just take a sum of this. These two should come as the same. As
No, this will not come same. This is 12 periods. This is 12 periods, no? We have to make it to 25 periods. So multiply into 2 plus 178479. Column C
Okay,
is a,
so
this is a period of, this is a total of 12 periods. Or 13 periods, I think. Can you check how many periods we have here?
we
13 periods.
have got 30.
So we have to add 12 into this equal to,
Okay. But did we not divide it by 2.25? Like this number should account for the demand. Like it is the sum of 2 periods. So
no,
that's why I
no,
was
this is not sum of 2 periods. It is per period. So this is 2
Okay.
period. So 2.25 period is one. It is 2 period, right? Yeah, 2 period demand it is. This is 2 periods. For 2 periods, we're getting an average. So this is coming around. This is for 12 again for 2 period demand. That's an average for 2.25 period demand. Every 2.2. This is an average for every 2 demand. Okay, so this is going to be into just this is going to be multiplied into. Just do find the 12 weeks demand here for the C column C 12 weeks.
12 weeks.
Yeah, 12 periods.
Okay, so I'll just refresh.
This coming around
This
211447. So 11 4
21 lakhs 21,000.
3368 3357. So this, if we add also, will not get that much. So here we have got the average of 451776. So in the first column B, take the average if condition. The column B for Bombay, B for Bombay, go to average and take only average. Yeah, take average if condition there. Take only for zero. Yeah, take only for more than zero.
Criteria is this number to be greater than 0.
So this is 941200. Now what is the for 2 period demand? Now we're getting.
Okay, so this number B31 is like this. Here I'm P31 by F32. So this is 418311, like 4,18,000 is the per period demand now.
Okay, now for 2 periods.
Okay, so I think this is the calculation P32 into 2. So now for 2 periods it is 3,71,000.
Okay, now put this number there. 371832.
So So this is the number. Now I have plugged this number like every 2 periods. Okay. So if I look at the sum, I have to see 29. So now my summation is coming to this number, 48 like something. The summation here is something else. It shouldn't the sums match?
They should be close enough. They should be close enough. So we are making one error. Somewhere we are making one error. So the average here is 2.25. We have a sum of how much? 11. We have a sum of 11,294. Okay. Now do one thing. Divide this 11,294.40 divide by 2.25. Divide this sum. Divide this sum. Yeah. Divide. Don't remove the average from there. 941,200. That remove that. Remove that and divide this sum by 2.25. Now put this number 501793 into the and now this number should be put everywhere, not just on alternate cell. Put in every cell 519773. Put in every cell.
Understood. Okay. So this was the overall sum. This is the total sum divided by F32, that is 2.25.
Every 2.25 periods. Let's make it 2 periods also. Same thing we can make it every 2 periods. Instead of making, where is 2 period calculation? I think we have some formula there, 2 period calculation. Make this is so now do one thing. Now we got 51973, right? That is for 2.2 periods. Make it for 2 periods now. Multiply it into 2.
Okay. So this number that I had should be multiplied with 2. We'll remove these things and it's a bit confusing.
Yeah.
This is B30 was this one divided by F32. That's okay. I'll remove this as well. What I'm going to do, this number gets multiplied with 2. So this is the number that I'm going to give you.
Yeah.
So a lot of sense. So we can go ahead and apply this thing. Replace. So this is the number I will. 100,036.67. This has to be replaced with 371,832.
No. We are doing the reverse. Replace with. Can you check once again? The replace. What is the replacement number here? Is 1003946, right? That is.
Yeah, I did the opposite. This is the number that should be replaced with this one. There is spaces. Yeah, just know it. This one.
Right, now it's coming something close.
Still there is a
that will be okay. I think that something will be over, right? 101. This is 11 lakh. Unit 100,000, 1 crore 12 lakhs 94,400. Here it is 1 crore 30 lakhs 51,000. How much it is? Unit and 100,000. 100,000 lakh 13 crores you're getting here.
Yes, so this is 1 crore, this is
13 crores.
This is a bit too much.
Yeah.
So I can actually try to delve deep and figure out what's happening here. That could be something I can work on today.
Yeah, that's I think okay. So here we are getting 13 crores, and this is skewed. This is definitely it will come high because it is skewed at March, April, May. If you look at the March, April, May numbers are higher, and rest of the numbers are lower. So that is why we're getting. So here, if you see 5019733 is a per week period. 5019733. 5019733 is a per 2.25 periods. If I divide, this is for 2.25 periods. So if I do one for one period, then it will be, if you do one thing, the calculations are there, right? The calculation is 100, row number 32.
Row number 32 cases.
Yeah, this is B30 by F32. So this is for 2.25 periods. Now for 2 periods, we are multiplying it. So for one period, it is 2.25 period. For one period is 2.2. Okay, for one period is this is 501,973. Now what we are doing is if we divide the total sum, if we divide the total sum by the 2.25, if we divide total sum by 2.25, then we're getting for one period. That is 501,793. 501,97 like 5 lakh 1,097. This is 50 lakh 19,000 50 lakh 19,733. 50 lakh is very high. 50 lakh is very, very high. We are dividing the sum. We're dividing the sum. We're dividing the sum by the. We're dividing the sum by 2.25. This is not right. We cannot divide the sum by 2.25. We have to divide the average by 2.25. Okay, we'll see it in the next session, right? So I think we cannot divide the sum by the 2.25. That's wrong.
Okay.
Because sum is the overall, and we cannot divide by 2.25. So just save the file. We'll do in next. I think there's some mistake is happening here, so we'll see it in the next session.
Yes, sir. Okay. Sir, I had a question. So there are some folks who did not join today. So if they join tomorrow, will they be able to follow?
They have to follow the recordings. No, or I forgot to record the session. Sorry, I forgot to record this session also. Anyway, no problem. So I think they will have to struggle. They don't have the recordings.
All right, sir. So
Okay.
tomorrow I will connect at 9:30.
Yeah, tomorrow 9:30 will connect.
Thank you.
Okay, Ananya, take care. Bye.
की संस्कृति में जो योगी और मुनि और जो सिद्ध पुरुष हुआ करते थे, उनके पास ये शक्ति होती थी, ये हम भी सुनते आए। लेकिन आपकी उम्र है सिर्फ 26 साल। जितनी आपकी उम्र है उससे दुगना या तिगना तपस्या करने के बाद जो योगी हुआ करते थे, हमारे जो ऋषि मुनि होते थे, तब उनके पास ये शक्ति आती थी पूरे सब कर सकते। आपकी उम्र ही टोटल 26 साल है, तो आपके पास वो चमत्कार जो शक्ति है इतनी जल्दी कैसे आई? आपसे किसी ने पूछा नहीं होगा, लेकिन आज भी दिन रात बहुत, अरे आपकी योग्यता का क्या कहना, आई प्राउड ऑफ यू, बहुत गर्व है आपकी लैंग्वेज से और आपकी स्पष्ट प्रश्नों से। देखो वो बाकी लोग तो वही कैसे बैठे क्वेश्चन करते हैं, आप ये जो बीच की नई चीजें लाई हो, तपस्या तपस्वी हम नहीं है, लेकिन दिन रात तपस्या में ही गुजरना 9 साल की तपस्या से बालाजी आके जब खेलना सीखते थे, तब से हनुमान चालीसा का पाठ आपको बताएंगे कि हमने क्या क्या इतना हनुमान चालीसा का पाठ किया, रातों भर हनुमान जी के चरणों में बैठकर रोए हैं, रातों भर हवन किया है, उसका ही एक परिणाम है जो आज संस्कृति का झंडा जगह जगह गाड़ा जा रहा है। जो भोले भाले लोगों को धर्मांतरण कर रहे थे छोटी छोटी क्लिप दिखाकर, ऐसे मिशनरियों के ऊपर तमाचा। भारत के इतिहास में नेशनल चैनलों के सामने कोई पादरी नहीं आया, कोई अन्य धर्मों के लोग नहीं आए, पर बाकी सिद्धांत देकर के ललकार तो आप तो इतना लोगों के मन की बात जान लेते हैं, अंतर्यामी आप हैं। इस समय आप तो देख रहे होंगे, क्या आप इस समय कोई हमें चमत्कार दिखा सकते हैं? कोई अंतर्यामी नहीं है और हम कोई भी अंतर्यामी नहीं, ऐसा कोई जो है अंतर्यामी होने का आज तक हमने दावा नहीं किया। अंतर्यामी सिर्फ और हम कोई जादू करने पे कोई भी बोले कि आप डमरू बजा दो तो चमत्कार दिखा दो, हम अपने इष्ट से प्रार्थना करने वाले एक याचक हैं। तो हमारे सामने तो जब वो आएगा देखिए, हम प्रार्थना करेंगे, वो सनातनी बनेगा, प्रार्थना करेंगे, हमारे बालाजी उस पर कृपा कर देंगे। लॉजिक सीधा सा है, फंडा सीधा सा है। पर मैजिशियन को ये डमरू बजाए, हाँ भैया जाओ खेल देगा। देखो प्यासा मां के पास जाता है, मां प्यासी के पास। धीरेन्द्र जी, मैंने देखा आपके पास किसी को बुलाते भी बिल्कुल। अच्छा, आप ये बताइए, मान लीजिए अगर कोई और धर्म का व्यक्ति आपके पास आए, कोई इस्लाम को मानने वाला आए, कोई ईसाई धर्म को मानने वाला अगर आपके दरबार में आए और आपसे मदद मांगे, तो आप सिर्फ सनातनियों के लिए ही मदद करते हैं, या अगर कोई इस्लाम को मानने वाला भी आपके पास आ जाए तो आप मदद करेंगे? बिल्कुल, मानव होने के नाते हमसे तो बहुत मुसलमान भाई भी जुड़े, बहुत क्रिश्चियन वाले लोग भी हमारे पास आते हैं, अन्य पंथों के लोग भी हमारे पास हजारों की तादाद में आते हैं। गिनती गिनवाने के कई दरबार में आप हमारे यूट्यूब खोजिएगा, यूट्यूब पर आपको लंबी लिस्ट मिलेगी, उसमें कहीं ना कहीं मुसलमान भाई का चार भाव वो जो माइक पे बोलते हैं, माइक मिल जाएगी आपको, हम आपको भिजवा देंगे, आप भिजवा देना लोगों को।
Yes, inspiration from India for the next Oceans movie. A gang of robbers actually made away with a 29-foot mobile tower. That's right. Taking just one capsule a day keeps your sugar level normal. Eight out of 10 people have seen results. Try it or share this with someone trying to cope with diabetes.
शराब पीते हैं, आप आलसी हैं, एक्सरसाइज नहीं। अगर इनमें से कुछ भी आप करते हैं तो सावधान हो जाइए, आपको कैंसर हो सकता है। अमेरिका के एक बहुत बड़े डॉक्टर ने
We know some people are quite obsessed with big showdown has erupted in India. There's a video. We've had in the past 1.5 years over 100 million women from poor stratas of society go to a medical institution, brick and mortar, across the country, get themselves tested for cancer of the cervix and breast cancer. Unimaginable. Because people presume that culturally this is not an acceptable term of conversation, especially publicly amongst Indian women. But what we have expressed is that when we have an access to a service, and when that access is also economical, we know how to use that service. So we've created that place for the world to reflect on. That as consumers, irrespective of whether you think our rural landscape has a potential or not, we have the intelligence to use digital services or the healthcare brick and mortar services and bring about a huge chunk.
For more information,
रसोड़े में क्या है? ग्रीन फलों से बनी एक छोटी सी डिब्बी है और उसको कहते हैं ट्रिफला ट्राफोजल।